Hey everyone, welcome back to the channel Code with AKJ. Today is day 22 of solving LeetCode 75 challenge. So today we are diving into an exciting problem from hash map or set technique, that is determine if two strings are close. So this problem combines operations on string with a touch of logic. So by the end of this video you will be able to understand how to approach it using brute force and how to optimize it for real world efficiency. So let's get started. So the question says two strings are considered close if you can attain one from the other using the following operations. So the operation 1 is swap any two existing characters, that is from the given example here A, B, C, D, E. Here they are trying to swap B and E characters. So after swapping these two characters, the string converts into A, E, C, D, B. So this is one of the operation we can use. So the second operation here is transform every occurrence of one existing character into another existing character and do the same with the other character. So for example here AACABB. So here they're trying to transform the occurrence of A and convert it into B. So after doing that particular operation, the string changes into BBCBAA. So here as you can see, all A's turn into B and all B's turns into A. So you can use these operations on either string as many times as necessary. So given strings word1 and word2, we need to return true if word1 and word2 are close and false otherwise. So the problem explanation is simple. So let's quickly understand this problem more clearly with the given three examples. So I've written here three examples and also the two operations we are going to use to convert this word1 into word2 or this word2 into word1. So let's look at our first example. Here word1 is ABC and word2 is BCA. So let's try to convert this word1 into word2. So let's take ABC and let's try to convert this ABC into BCA. So from the word2 we can see that the A is at the end of this string. So let's try to swap first these two characters, that is A and C. So after using this first operation, that is swap any two characters, the string changes to CBA. So still it is not equal to word2 or still it is not close to word2. So let's try to use another operation or use the same operation to convert this. So since B is at the starting of the string, so let's try to swap these two characters, that is C and B. So after swapping these two, the word changes to BCA. So now we can see that BCA is equals to word2. So since after using these two operations, the word1 is converted to word2. So in this case, we'll return true. As we are able to convert this word1 into word2, we can conclude that these two words are close. So this was first example. So let's look at our second example here. So here word1 is A and word2 is AA. So if we carefully observe this given word1, here the length is 1 and here the length of word2 is 2. So if you try to use any of this operation, that is operation 1 or operation 2, we cannot convert word1 into word2 or word2 into word1. So in this given example or in this case, we'll return false as the length of these two words are not equal. So from this given example, we can understand that and we can conclude that there is a base case, that is the length of word1 should be equal to the length of word2. So let's look at our final example, that is example 3. So let's try to convert this word1 into word2. So here in word1 there's one more B here. So initially let's try to group all these characters at one place. So we'll swap these two characters, that is B and A. So the word converts to CAA, B, B and B. So now we'll use the second operation, that is transform every occurrence of first character with the other character's occurrence, that is we'll transform the C's occurrence with B. So after using operation 2 here, the word becomes B, A and C, C, C. So till now we have used two operations, that is swap any two characters and the second operation, that is transforming the occurrence of two characters. So again here, since we have two B's and single A, we'll try to use operation 2 again with these two characters B and AA. So finally we'll get A, B, B and C, C, C. So here, after using three operations, we have converted our word 1 into word 2 successfully. So in this example, we'll return true. So let's get started with our brute force approach. So in our brute force approach, it would typically involve trying every possible way to transform this word 1 into word 2. That is, we're gonna generate all the possible strings from this given word 1, and by performing these two operations, operation 1 and operation 2, we'll check if this word 2 exists in that particular set. That is, we'll try every possible way to transform word 1 into word 2, that is including swapping every pair of characters explicitly and attempting to all possible transformations between pairs of characters, and we'll test all the permutations which could result in factorial way. So generally we're gonna generate all the possible permutation of this given word and we'll perform these two operations, operation 1 and operation 2, and we'll check whether it matches with our word 2 or not. So this would be our brute force approach, where we are gonna generate all the permutation which would take O of n factorial way, and also to perform these two operations explicitly, it would take more n square time complexity. So however, such a solution would be computationally infeasible for any string of significant length due to exponential time complexity, but it's still a brute force approach. So let's quickly look at the code and let's try to submit whether it gets accepted or not, and then we'll move on to our optimal solution, where we are going to use another way of solving this problem statement. So this is a code for the brute force approach we have discussed. Here the initial base case would be to check whether these words have same length or not. So this is the main case where if the size of both the words are not equal, then we'll return false. So here I've used another set to keep track of visited string to avoid infinite loops, since we are gonna generate all the permutation of word. Here we are also using queue. We'll start with the BFS with the initial string, and we'll also mark it as visited in our ordered set. So we'll use a loop. We'll take the front string, that is current string. So if we find the target string, that is if the current string is equals to word 2, we'll return true. So here we'll perform the first operation, that is we'll generate all the possible strings by swapping any two characters, where we are going to use two for loops to swap each and every character, and we'll also compare it with our unordered set whether it matches with our word 2 or not. So if it does not matches, we'll push it into the queue and we'll also mark it as visited. So this would be our second operation, that is generating all the possible strings by transforming one character to the another. After converting and after doing this following operation, we'll also check whether it already exists in our unordered set or not. So if not, we'll push it into the queue and we'll mark it as visited. So in this way, this while loop runs and it checks for all the possible strings of word 1, which takes O of n factorial times n square. So after all this, if we didn't found any word that matches with our word 2, then we'll return false. So let's quickly run and submit. As you can see, this approach gives us time limit exceeded, which is highly inefficient for any kind of string. That is, we are using O of n factorial times n square time complexity here, and same goes with the complexity as well. So let's quickly optimize it. So let's optimize our approach. So to optimize it, let's think logically. So for the two strings to be close, they must have same set of unique characters, and the frequency of each character when sorted should match, and also the length should be same. So in our optimal approach, there would be three steps. So the first step here would be to check if both strings have the same unique characters, such as A, B, C. In this given example, as we can see here, these two words have same unique characters, that is A, B, and C. The words and the both words should have same length as well. So this would be our second observation, and the third observation here would be to count the frequency of each character in both strings. We'll sort the frequency arrays and we'll compare it. So in our third example, we can easily understand it. So in word 1, the frequency of A is 2, the frequency of B is 3, and the frequency of C is 1. Whereas in word 2, the frequency of A is 1, B is 2, and C is 3. So if we try to sort these frequencies, we'll get 1, 2, and 3. and same goes within word 2. If we sort the frequency, the values would be 1, 2 and 3. So this should match. So these are the three observations we should find from these given three examples, and by analyzing these three examples, this would be the three steps we would follow in our optimal approach. That is, check if both strings have the same unique characters, and the length of word 1 should be equal to length of word 2, and the frequency of each character should match when sorted. So here the time complexity would be, so the counting characters and sorting array takes O of n plus k log k, where n is the string's length and k is the number of unique characters. So this would be our optimal approach, where we are gonna use map and set as well. So let's quickly code this approach, and let's also do a dry run with these three examples. So this is a code for the optimal approach, where we are gonna use both map and set. So here the first step would be to check if the lengths of these two words are same or not. So if they are not, we'll return false. So the step 2 here would be to count the frequency of each and every character of these two words, word 1 and word 2. I have used two frequencies, frequency 1 and frequency 2. Step 3 here would be to check if these two strings have the same unique characters. So to handle the unique characters, we'll use set. Here I have used unique 1 and unique 2. And if they are not unique, we'll return false. And finally, our step would be to check if the frequency of each and every characters of both the words are same or not after sorting. So we'll take the frequencies and we'll store it in our vector frequency list 1 and 2. We'll sort those vector and we'll finally check if these two vectors are same or not. So in this way, we'll be handling these three cases, and with the help of map and set, we are gonna solve this problem statement. So let's quickly run this code. So okay, so let's submit. So as you can see, this way of solving this problem statement gives us successful submission. So here we have used the power of both map and set, and also derived our approach by analyzing these three examples. So it is important to read this problem statement carefully and try to take the insight from it. So let's quickly dry run these three examples with this given code. So let's quickly do a quick dry run of our optimal approach on these three examples. So in our example 1, so our first step here would be to check if the lengths are different or not. So here the length of word 1 is 3 and the length of word 2 is 3. So lengths are same here. So the second step here would be to count the frequency of each character in both strings. So the frequency of word 1 characters are A is 1, B is 1 and C is 1. Whereas in word 2, A is 1, B is 1 and C is 1. Third step here would be to check if both strings have the same unique characters or not, and we are gonna do it using set. So we'll insert all these characters in our set. So in our first set, the characters would be A, B and C, and in our second set, the characters would be A, B and C. So our fourth step here would be to check the frequency distributions, if they are getting matched or not. So the frequency is here. We are gonna store the frequency of these two words characters in two different vectors. So in this given vector, the frequencies would be 1, 1 and 1. Whereas in this vector, the frequency is gonna be 1 and 1 and 1. And finally, we'll compare whether the size of these two vectors are same or not. So since they are same, we'll finally return true here. So in this given first example, our answer would be true. So let's do the dry run on this second example. So again, the first step here would be to check if the lengths are same or not. So the length of word 1 is 1 and word 2 is 2. So since they are not equal, that is the word 1 is not equal to length of word 2, we'll directly return false here. So in this given example, our answer would be false. So for our final example, so the step 1 here would be to check if the lengths are different or not. So the length of word 1 would be 6 and the length of word 2 would be 6. So it passes the first step. So here the second step would be to count the frequency of each character in the both strings. So in word 1, the frequency of A is 2, frequency of B is 3, frequency of C is 1, and in word 2, frequency of A is 1, frequency of B is 2, and frequency of C is 3. Step 3 here would be to check if both strings have the same unique characters or not. So we are going to use set here. So in set 1, we have characters A, B, and C, and in step 2, we have characters A, B, and C. And we'll check whether they are unique or not. So since they are unique and since they have same unique characters, so the step 2 is passed. So our final step here would be to check if frequency distributions are matched or not. So the frequency distributions are stored in the vector. So the values would be 1, 2, and 3 when they are sorted. And same goes with the word 2, that is 1, 2, or 3 after they are sorted. So after doing this particular operation, we are going to check if the sizes of these two vectors are same or not. So since they are same, so the step 3 is also passed. So in this given example, we'll return true as it is passing all the given conditions. So in this way, we are going to solve this problem statement using both map and set by analyzing these 3 examples and deriving all the following conditions here. So the time complexity of this approach would be O of n plus k log k, and space complexity would be O of n. Let's quickly do a time complexity and space complexity analysis. So in our brute force approach, we have generated all the possible permutations of given word 1, and we have performed both operation 1 and operation 2 on it, and we have checked with our word 2 whether it matches or not. So generating all the possible permutations of given word 1 takes O of n factorial, and also performing both the operations on it and also checking it with word 2 takes n square time complexity. So the time complexity of this brute force approach was highly inefficient for any kind of string. Space complexity of the brute force approach is also high. Whereas in our optimal approach, where we have used both map and set concept, the time complexity is O of n plus k log k, which is far more better than the time complexity of our brute force approach, and space complexity is also far more better than our brute force approach space complexity. And that's it for today. We have seen how to determine if two strings are close using both brute force approach and the optimal approach. So the key takeaway here is understanding the problem's constraints and leveraging sorted frequency arrays to reduce our time complexity. So if you found this explanation helpful, make sure to hit the like button and subscribe for more coding tutorials. Also comment below if you like me to cover a specific problem next. I'll see you in the next video. Thank you.